Hello, my name is Satish Yadav and I welcome all of you on behalf of Wallah and our team Drona. Now, we will try to understand today's topic, and today's topic is basically the derangement. If you try to understand the name of this topic, derangements, nothing is in its right place. It creates a curiosity of what? See, whenever we are into the 10th standard, 11th standard, we always have been understood one particular topic that is called as the arrangement. Arrangement of what? If you'll be having a 3 elements A, B, C, you will try to arrange, and you can easily arrange in a 3 factorial ways. But this topic is little bit different. So you will be enjoying this topic. So let's try to understand basically what is a derangement. See, if you'll be having this derangement, first we'll try to understand its name suggests that nothing is at right place. What is, what you can say that nothing is at right place. So for example, let's consider there are 3 students, 1, 2 and 3. They are going to college or a school, whatever you can consider. They are going and they are sitting on each and every day on the same bench. So first student is sitting on the first number, second student is sitting on the second number, and third student is sitting on the third number. Now, can we say that how many ways you can arrange this sitting arrangement so that the first student is not sitting at the first place, second student is not sitting at the second place, third student is not sitting at the third place? Can we say that it is interesting? Yes, we can say that it is interesting, and it is very interesting topic. So we'll try to understand the derangement, we'll try to understand the definition of it, and we'll also try to understand one gate questions related to that, and I will take you to the depth of its concept. Okay, let's try to understand. Or another way of saying that, let's consider there are 3 people who are going to one particular restaurant, and then they are having their respective coats. Coat number 1, coat number 2, or coat number 3. Or you can also consider as a hat. Hat number 1, hat number 2 and hat number 3. Suppose if they are going to a restaurant and they have submitted their hats, respective hats at the counter. Now, while coming back, how many ways you can arrange this such that none of the person is getting the same hat? Is it interesting? Yes. Okay, let's try to understand the basic definition of this. The derangement of n distinct symbols which have some natural order is a permutation in which no symbol is at correct position. Or in a simple term, I can say that nothing is at right place. It is such an arrangement such that you are not getting the element sequence in its right place. What is the basic representation? So if I can give you 1 or 2 simple examples. Suppose here, if I will be writing D of n, what is this? Dearrangement of n particular elements. Now if I will try to say that what is D of 1? D of 1 is dearrangement of one particular element. What is D of 2? D of 2 is dearrangement of 2 particular elements. Okay, let's try to understand. For example, as I can also have one beautiful diagram over here just in order to understand this. See, for example, let's consider there is a postman, and this postman is carrying a letter. Letter number 1, letter number 2, letter number 3. And there are 3 addresses. So how many ways you can say that these postmen are not delivering the correct letter to at correct position, such that letter number 1 should not go to address number 1, letter number 2 should not go to address number 2. So this is a combination that we have to understand, and believe me, it is very interesting topic that we can learn over here. Now, if I will try to understand about dearrangement of 2 elements. For example, here if I will be having element number 1, element number 2. So how many ways you can dearrange such that letter number 1 will not be at first position, and how many ways you can say that letter number 2 will not be at the second position. So what you can do, you can write 2 here and then you can write 1 here. So we can easily say that they are not at correct position. So how many ways you can do it? So that is why for D2, what we can say? For D2 we can say there is only one way we can do this. Now let's talk about the 3 elements. So suppose if I'll be having a 3 elements, what we can do? See here, 1, this is 2, this is 3. Now if we'll be having a 3 elements, how many ways we can do it? So in order to do that, I'll be adding one slide so that I can show you the very beautiful pictures here. So you'll be having a 3 elements, 1, 2 and then 3. So first what I will do, I will try to write down all the possibilities, and the total possibilities are basically 3 factorial possibilities. I will try to write down all the possibilities and I will show it which elements or which possibility is not at right places. So here first possibility is 1, 2, 3. Second possibility you can write 1, 3, 2, or here you will have a 2, 1, 3 or 2, 3, 1, or this is 3, 1, 2 and then this is 3, 2, 1. Now let's try to understand with the help of some representation. See, can we take 1, 2, 3? No, we cannot take 1, 2, 3. Why we cannot take 1, 2, 3? Because 1 is at right place, second is also right place, third is also right place. So we cannot take this. Now, can we take 1, 3, 2? No, we cannot take 1, 3, 2 because 1 is at right place. That is why we cannot take 1. Now, can we take 2, 1, 3? No, we cannot take 2, 1, 3 because 3 is at right place. So, sir, are you trying to say that ki at least one element should not be at right position? Yes, at least one element or two element or any type of element. The element should not be at the right place. Now, can we take 2, 3, 1? See, 2 is we are sitting or we are arranging 2 at first position, 3 at 2 position, 1 at 3 position. So we can take this 2, 3, 1. So this is one way we can do the dearrangement. Now let's talk about 3, 1, 2. Can we take 3, 1, 2? Yes, we can also take 3, 1, 2. So here this is another way of dearranging an element. Can we take 3, 2, 1? No, we cannot take 3, 2, 1 because 2 is at right position. So I hope you people have got a little bit idea about a dearrangement. This is with respect to 3 elements. So that means with respect to 3 elements, we have to write down all the 3 factorial possibilities, and out of that, what I have done, manually I am going and I am counting. Is it at right place? This is at right place. This is at right place. This is at right place. So it will take a lot of time. See, right now it is a 3 element. So we can write 3 factorial and we can easily try to find it out all the things. What about if we will be having 4 elements? So if we'll be having 4 elements, let's take 1, 2, 3 and 4. So for this, again we have to do, that is nothing but 4 factorial possibilities. What about 5 elements? What about 6 elements? See, your n factorial, it is going very large amount of, see, for example, for a 4 factorial, we have to go for 24 possibilities. For 5 factorial, we have to go for 120 possibilities. So sir, is there any formula so that we can go and we can derive it? Yes, definitely we are having one formula. So let's try to find it out, that formula. Okay, so if I'll be talking about the 4 elements, so here if I'll be talking about 4 elements, you will be having total 9 possibilities. This is just, I'm trying to show that this all are the 9 possibilities, which is, in that way we can say that these elements are not at right position. So that is nothing but D4, you will be getting 9. So till now what we are having, D of 1, that will become 0. Why D of 1 is 0? Because one element, how many ways you can dearrange? There is no possibility. And for D2 we have already understood, that is nothing but 1. For D3 we have already understood, there is 2 possibilities, just now we have shown it. Now for D4, that will be getting a 9. So now let's try to find it out. We have to also find out for D5. We also have to find it about a D6. So we have to go and we have to search it. But obviously, if your number of elements are increasing, if it will become 5 elements, if it will become 6 elements, then you have to go for 5 factorial ways, and out of the total 5 factorial ways, you have to find it out. This element is right position or not. This element, it is a very tedious job. So what we will do? We will try to go with the formula. So let's try to derive one formula. But what is the basic of a formula? If you will try to see that with respect to here, see, if you will try to see that with respect to this, what I have done, in order to find it out, okay, in order to find it out, let's consider this. In order to find out D3, what I have done, I have written all the possibilities. That means I have written 3 factorial, and out of that, what I have done, at least one element at right position. At least one element at right position. One element at right position. So basically here you will be having this particular this particular concept. So what it is trying to say that if you want to find out about D3, then first you have to write down all the possibilities. That means 3 factorial. So once you have written all the possibilities, out of that I have removed this, I have removed this, I have removed this, and I have removed this. So that's how I'll be getting our answer. So the total is basically 6, and out of that I have removed 4. So my answer I'm getting is basically 2, and these 2 are basically the possibilities. So we got a little bit idea about it. What it is trying to say that at least one element at right position. So total minus at least one element at right position, what will be your answer? Your answer will be none of the element at right position. It is very simple. Let's try to find out for D4 and all the concepts that will be related to this. For example, if I want to find it out about D4, so D4 you can say that it is a 4 factorial, and it says that at least one element at right position. What it says that at least one element at right position. Please, just try to understand. total minus at least one element at right position, then what you will get answer? You will get answer none of the element which is at right position. That is the basic definition of a derangement. So here at least one element at right position. Now how we can try to understand this? So we are trying to in a process of deriving the formula. So here 4 factorial minus a1 union a2 union a3 union and a4. Now what is this? What is the representation of a1? The representation of a1, it says that this is a number of possibility where the first element at right position. So it is, we can say that ki number of ways, okay, number of ways where, okay, number of ways where first element at right position, first element at right position. So let's try to find it out. First element at right position. So how we can say that? So a1 is a number of ways where the first element at right position. So you can say that ki 1 and then 2, this is 3, this is 4. So actually you are fixing 1 for some particular possibilities and then you are jumbling these 3 elements. So how many ways you can jumble these 3 elements? Can we say that it will become in a 3 factorial possibilities? Yes or no? Like 2 3 4 or 2 4 3 or 4 3 2 or 4 2 3, where you are fixing the first element. So a1 is a total number of possibility where you are fixing the first element and then you are jumbling these remaining 3 elements. So can we say that the total possibility you will be getting is basically 3 factorial? In the same way, if I will be taking a2 in the same way a2 will also come as a 3 factorial. a3 is what? You are fixing the third element and then you are getting another possibility is 3 factorial. And here a4 you are also fixing, so you will be getting 3 factorial possibilities. Yes or no? So let's try to derive what is this a1 union, a2 union, a3 union and a4 union. So what I can write it over here is basically some concepts like this. See, your a1 union, a2 union, a3 union, a4, and now we will try to find it out. A1 is a total number of ways where you can fix the first element and then you can jumble the remaining. Now what is my point is what will happen if a1 intersection a2. a1 intersection a2, it says that number of ways you can put first and second element at right position, right? First element and second element at right position. So if you will be fixing first element and second element at right position, how many ways you can jumble the remaining 2 elements? You can jumble the remaining 2 elements in a 2 factorial ways. Understood? Yes or no? Now if I will say that a1 intersection a2 intersection a3, so that means what it says that? It says that number of ways you can fix first, second and third element, and how many ways you can jumble the last element? You can jumble the last element in how many ways? 1 factorial ways. Yes or no? And what it says that? It says that a1 intersection a2 intersection and then here you will be having a3 intersection and you will be having a4. So what it is trying to say that? It is trying to say that the number of possibilities where all element at right position, where first element at right position, second element at right position, third element at right position and fourth element is right position. So how many ways you can do it? There is only one way we can do it. There is only one way we can do it. That is nothing but first element at right position, second element at right position, third element at right position and fourth element at right position. There is only one possibility is like that. Okay, so we'll try to understand about it. So how we can try to say that it is a1 plus a2 plus a3 plus a4. So summation of ai and then after that minus. So again here we are trying to come up with the properties of inclusion and exclusion, right? So what is inclusion and exclusion? In a distinct counting, whenever we count something wrong, we try to add something. That is called as the inclusion. What is exclusion? Whenever we are over counting something, we have to remove something. That is called as the exclusion. So that is a basic property of inclusion and exclusion. So sir, are you trying to say that derangement is a property of or you can say that application of inclusion and exclusion? Yes, we can easily say that it is a property of inclusion and exclusion. Or if you want to understand about inclusion and exclusion, I can try to tell you here. Let's consider there is a 4-year child and here there are 3 coins. And if I will tell to this person, go and count it. So this person will be counting it like this. This is 1, this is 2 and then let's consider this is 3 and then this is 4. So this person has over counted something. So in a property of a distinct counting, how many total number of coins we are having? We are having distinct counting as 3. but this person has counted wrong. This person has counted 4. So what we will do, we will try to remove 1 from here, and then the real answer will become 3. This is the property of exclusion. So when we are counting something over, then we have to remove something, and then we'll try to do minus, and hence we are getting answer as a 3. Now, if I will be having a 3 elements, let's consider if I'll ask to another child, you come and you tell me how many coins over here. This person is counting, this is 1, and then this is 2. Now, this person has counted 2. Now, this person, can we say that it is a distinct counting? No, it is not a distinct counting. So, what we have to do? We have to add one element into that. So, here it will become 2 plus 1, and then the answer you will be getting is basically 3. So, this is called as the exclusion, that is called as the inclusion in a simple term. Or, you know, what I can show you is basically the one property that everybody is trying to understand from a very large amount of time. So for example, you know, this is also you people are using into the probability or in a set theory. Suppose if I want to count A union B, so what you are doing, you are first writing as a. That means you are counting as a. So you will count A as a 1 time, this middle part you are also counting as a 1 time, and then after that you will be counting B. So you are counting this B as a 1 time, and then you are counting this middle part as a 2 times. So here you have over counted it. Now what we have to do? We have to remove A intersection B. So if you will be removing it, so what will be happening? So in this way, what will be happening over here? So out of 2, one thing will be got out, and then you will get a distinct counting. Okay, let's move to our original topic here. What we are trying to say that ki A1 union A2 union A3 union A4 in this manner. So first we have to add A1. A1 is a total possibility where the first element at right position, plus A2. A2 is a total possibility where the second element at right position. In the same way for A3, in the same way for A4. And then we have counted something extra. Now what we have counted something extra, let's try to find it out over here. See, for example, A1 is a total possibility where the first element at right position, and then the remaining what you are doing, you are writing in a 3 factorial ways. Now if I will try to say that ki A2 is a total possibility where the second element, this 2 it at right position, and then the remaining you can, how many ways you can jingle it is basically 3 factorial. Now, in some possibility you may get where the 1 will come here and 2 will come here. Some possibility you will get 1 here and 2 here. So this you are counting as a 2 times. Then what we have to do? We have to remove it. So that is why here what we can say that ki AI intersection AJ, and then again we have to add it. This is the property of, you know, inclusion and exclusion. This is AI intersection AJ intersection AK, and then minus, that is nothing but A1 intersection A2 intersection A3 intersection A4. Okay, so in this way we have to go and we have to find it out all the possibilities that will be related to that. Okay, let's try to find it out. What are the possibilities that we are having over here is something like this. Now we can say that ki if you are counting A1, A1 means total number of possibility where the first element at right position. So what we can say that how many total possibilities you will be getting is 3 factorial. For the same way for A2 also you will be getting 3 factorial. For the same A3 also you will be getting 3 factorial. So can we write this as 4 into 3 factorial, because A1 is a total number of ways where the first element at right position, A2 is a total number of ways where the second element at right position, A3 third element at right position. After that what will happening here? Now everyone try to understand these things. This is very important, the next topic. Now 4 into 3 here where A1 plus A2 plus A3 plus A4, or if you want to go for in another detailed manner, then I can write it here A1 plus A2 plus A3 and then plus A4. Now we have to remove 2. That means here you will be removing A1 intersection A2. This is one possibility. So how many ways you can do it? A1 intersection A2, it says that where the first and second element at right position, this you can do in how many ways? 2 factorial ways. Now another way is A2 and then A3, again you can write in 2 factorial ways. Then another A1 intersection A3, this also you can write in 2 factorial ways. So what I can say that ki A1, this is A2, this is A3, this is A4. Out of this 4, we have to choose 2. I mean 2 combinations. So how many ways we can do it? That we can do it in 4C2 ways. 4C2 ways to choose 2 combination of it. And how many ways we can find it out, the jumble of this? So you will be getting 2 factorial. So 4 into 3 and 4C2 into 2 factorial, and then the addition will become 4C3 into 1 factorial, and then last one you can write it as 1. So now here this is the basic of that, and we can derive the formula based on that. I hope you people are getting it. But we will try to take this and we will try to submit it in our original form, and that is nothing but this is our original form. So what is the answer we are getting it here? So the first one is basically 4 into 3 factorial minus 4c2 into 2 factorial, and then plus 4c3 into 1 factorial, and then here you will be getting minus 1. Or if you want to understand about inclusion and exclusion, it should be alternate plus and minus. So that means if it is a first plus and then we will be going for minus, plus and then minus. That is the basic property of inclusion. Okay, inclusion and exclusion. If it is a 2 element, so first we have to add and then minus. If it is a third element, 3 elements, A, B, C, addition, minus, and then addition. If it is a 4 element, addition, minus. It is basically alternate ways of adding and minusing. Okay, so basically here we will be having our formula is ready. Now we will try to go and we will try to derive our formula. So I will be taking this and I will be trying to derive the formula. Okay, let's come to this particular point over here. So here if I will try to go and if I will try to understand these things, okay, so what is basically our D4? Our D4, it is trying to say that here 4 factorial minus you will be getting 4 into 3 factorial minus 4c2 into 2 factorial plus 4c3 into 1 factorial minus 1. Now first of all you will try to understand. I will take minus inside. So here you will get 4 factorial minus 4 into 3 factorial plus 4c2 into 2 factorial minus 4c3 into 1 factorial, and then here you will be getting plus 1. Now the first thing that try to understand, please try to focus here. I will remove this and this. You know why? Because 4 into 3 factorial is basically your 4 factorial. So I can easily remove it. Now let's take 4c2 and we'll try to derive our formula. So here you will be having 4c2 into 2 factorial minus 4c3 into 1 factorial and then plus. Okay, now in order to go for a formula, I will try to write down something like this. 4c2 can be written as 4 factorial divided by 2 factorial into 2 factorial and then into 2 factorial. Minus 4c3, I can write it as 4 factorial divided by 1 factorial into 3 factorial, and then I can write 1 factorial. Now see, everything is in the form of 4 factorial, 4 factorial. So 1, I can also write something in the form of 4 factorial, and that is divided by 4 factorial. Why I have written 1? Because you can write, see, in a mathematics you can write anything like this. So 1 divided by 4 factorial divided by 4 factorial. And we know why I have done it. I have done it because I have to take 4 factorial as a common. Now if you will try to understand here, so this 2 factorial, this 2 factorial will be out, this and this will be out. So if you will take 4 factorial outside, you will be getting 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial. So this is basically nothing but our formula. So we are ready with the formula. If you will try to solve it, you will get answer as a 9. So in the previous slide, I have given you the manual calculation about 4 element, dearrangement of 4 elements, and it will become a 9. So here we got our formula, that is nothing but 4 factorial. So now we can design a new formula for that, such that if I will be having a D4 you can write as a 4 factorial, and then here you will be getting 2 factorial minus 3 factorial, and then here you will be getting 4 factorial. This is a formula or derivation for a 4 number of derangements. If I want to calculate for D5, inside you should be having a plus and minus. So here I can write as 5 factorial, 1 upon 2 factorial, minus 1 upon 3 factorial, plus 1 upon 4 factorial, and then minus 1 upon 5 factorial. So if you will try to calculate, you will get answer as a 44. Here you will get answer as a 9. So now this is a general formula, we got it. Now if you want to find out the derangement of n number of elements, I can write as n factorial and 1 upon 2 factorial minus 1 upon 3 factorial and alternate plus and minus 4 factorial. Now in this way we can write minus 1 upon n, and here I will be getting n factorial. So this is nothing but our formula. See, if it is a 2, you will get positive. If you will get odd, you will get negative. If it is a positive or if it is a even number, you will get positive. So if you will put n equals to 2, you will get positive. If you will put n equals to 3, you will get negative. So basically it is an alternate way of calculating it. So I hope you people have understood how I have derived the formula. So actually your question will not be changing into gate examination. So for example, if 5 people are going into a restaurant and they are having their respective hats, in suppose if they are coming back, how many ways so that none of the people are getting the right, hats. So how many ways we can say that this question is changing to D5. So can you calculate D5? Yeah, here we are having the formula and we can easily calculate the D5, right? The same question, if the 3 people will go, it will become D3. If 4 people will go, it will become D4. So your question will not be changing. So in gate examination, the most problematic thing is if in combinatorics is basically if you can find it out which type of question is this. If the question is basically of derangement, you can easily, you can use the formula and you can try to solve it. If the question is based on pigeonhole, try to identify the problems. So in combinatorics, identifying the problem is one of the problematic thing that you people can have it. Okay, let's try to see one gate question and we can easily try to understand. So here, in how many ways can we can we distribute 5 distinct balls B1 to B5? So here you will be having balls B1, this is B1, this is B2, this is B3. So understanding a problem is very, very important. So here you will be having a 5 balls, 5 distinct cells. So you are arranging 5 balls to a 5 distinct cells. So here C1, this is C2, this is C3, this is C4, this is C5, such that the BI should not go to CI, right? So actually they are trying to find it out what is D5. So if you can try to find it out about D5, you will get answer which is nothing but 44. So I hope you have understood. Now if they are giving that 6 ball has to go to 6 holes, then you can try to calculate for D6, in the same way for D7, in the same way for D8. So I would recommend from D1 to D6 or D1 to D5, if you know the value, that will be very helpful. So within a second you can solve this question. You do not have to worry about it. So always remember, in a combinatorics or in a counting problem, if you are not getting the answer, that means you cannot find out the category of a question. If you can find out the category of a questions, it is very important. So either it belongs to pigeonhole, inclusion or exclusion. Try to understand the category. So right now I'm taking one category and that is nothing but derangement. Okay. So I hope I have given you the formulas and I have given you how to derive the formulas and I have given you how to calculate it and I've told you the definition of a derangements. But I want to give you one more information that will be very important with respect to this, is something like that. Suppose if I will be having any particular concepts here, you might be having the Taylor expansions. So if I will be writing e raised to x, this is little bit different for a computer science student. So let's try to write it down. The Taylor expansion, here you will get 1 and then here you can write x and then 1 factorial. This is x2 and then it is 2 factorial. Here it is x3. This is 3 factorial and likewise. Now suppose what will happen if I will put x equals to -1. See, if I will try to put the x equals to -1, here you will be getting e of -1. You can write 1 and then -1 upon 1 factorial and then plus you can write -1 square upon 2 factorial and then -1 raised to 3 upon 3 factorial plus -1 raised to 4 upon 4 factorial. Now if you will try to calculate this, you will get 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial and so on. Can you understand these things? Same we have already derived it and now here you will get e of -1. Now if you will try to understand the formula, in a derangement, d of n you have written as n factorial divided by 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial and likewise. Now these things just now we have derived and then it is almost equivalent to, this thing is almost equivalent to e of -1. Now you can say that your d of n is almost equivalent to n factorial into e raised to -1 and everybody knows that the value of Euler number, that is 2.708. Now if you will try to calculate here, you will get 0.368. Now if I will say that d of n will be divided by n factorial, it is almost equivalent to e of -1, which is almost equivalent to, you will be getting 0.368. Okay, so I hope you people have understood. Okay, so d of n divided by n factorial, you will be getting 0.368. See what it is trying to say that, it is trying to say that the probability of getting dearrangement elements for more than 5 elements will always be 36%. Sir, I have not understood. What I'm trying to tell you here is basically something like that. See, if you want to calculate for D5, if I will be taking n equals to 5, so here D5 divided by 5 factorial, it is almost equivalent to E of minus 1. So D of 6 and then 6 factorial, it is almost equivalent to E of minus 1. That is nothing but almost here you will be getting 0.368%. So what I'm trying to tell you, कि dearrangement of 6 elements, in a 6 factorial total possibilities, 36% elements are in a dearrangement form. In a 5 elements, 36 elements, 36% elements will be in the dearrangement form. So this is in gate question also. If they are trying to find it out what is D7, so instead of going with the formula, you can also try to write it down. D7 divided by 7 factorial, it is almost equivalent to 0.368. So if you want to calculate D7, what you will do, you will try to multiply 368 into 7 factorial. So in this way, you can easily calculate it. So I hope I have given you the plenty of information. I have taken you one step ahead of gate, and then I have given you the dearrangement, all the possibilities. Okay. So I hope you people have understood each and every concepts what I have taught it. So I told you the definition of dearrangement. I have given you the proof of the formula, and then I have given you the gate question, and I have taken you one step ahead. So I hope you people have understood. Thank you so much for joining me.